Which of these can you draw in one stroke without lifting your pen or going over any line twice? Your gut says the plain little window is easy and the busy star is hard. Your gut is exactly backwards. The simple window cannot be done at all, no matter how long you try. The tangled 5-point star can be done easily in one smooth stroke, so it is genuinely not about how complicated the figure looks. Something else entirely decides it, and once you know what, you never have to guess again. The thing that decides it is hiding at the corners. At each corner, count how many lines meet. Corners where an odd number of lines meet are the whole story. Here is the rule, and it needs no trial at all. If a figure has 0 odd corners, you can draw it in one stroke and finish where you began. If it has exactly 2 odd corners, you can still do it, starting at one and ending at the other. But if it has more than 2 odd corners, 3, 4, or more, it is simply impossible. No clever path exists, and no amount of trying will find one. So the entire question comes down to a single count. 0 or 2 odd corners, yes. Anything more than 2, no. Here is why. Every time your pen passes through a corner, it uses 2 lines at once, one to arrive and one to leave. In, then out. So any corner the pen just passes through must have an even number of lines. So a corner with an odd number of lines cannot be a pass-through. It can only be the place you start, with one spare line out, or the place you finish, with one spare line in. A single stroke has one start and one finish, so at most 2 odd corners are allowed. Try the rule on this envelope figure. Color each corner by how many lines meet there. The 2 bottom corners are odd, shown in coral. Every other corner is even in green. Just 2 odd corners in the whole figure. So the envelope draws in one stroke, guaranteed, and the rule even tells you how. You must begin at one coral corner and end at the other. No guessing, no failed attempts, just a count and a starting point. Now the simple window that fooled us at the start, color its corners the same way. The 4 edge midpoints each have 3 lines meeting, so all 4 are odd, all coral. 4 odd corners is more than 2, so the window cannot be drawn in one stroke, ever, by anyone. Its clean, simple look was a red herring all along. The star had 0 odd corners and sailed through. The window has 4 and cannot. Only the odd count decides it, never the appearance. So never judge a one-stroke puzzle by how tangled it looks, and never grind through paths hoping one works. Just walk the corners and count how many are odd. 0 odd, you can loop it and end where you started. Exactly 2, you can do it starting at one and ending at the other. More than 2, do not even try. One count settles it. Your turn. Here is a figure like a rectangle with a bar across the middle. Count its odd corners, then decide. Pause and try. Go corner by corner. The 4 outer corners each have just 2 lines meeting, so they are even green. Only the 2 ends of the middle bar have 3 lines each, odd, and they turn coral. 2 odd corners in total, so yes, it draws in one stroke, starting at one bar end and finishing at the other. One more. A square with a single diagonal across it. Count the odd corners and decide. Pause and try. The diagonal adds a line to 2 opposite corners, making them odd, 3 lines each. The other 2 stay even. 2 odd corners again, so yes, start at one diagonal corner and end at the other. This little rule started one of the oldest puzzles in mathematics, the bridges of a town called Königsberg, and it still runs the real world. Planning a postman's round, a snowplow route, or a street sweeper, all of it turns on the odd corners. Count the odd corners, and you already know the answer before you draw a single line. That is the quiet power of finding the right thing to count. So whether a figure draws in one stroke has nothing to do with how busy it looks. Walk its corners, count how many are odd, 0 or 2, and it is one clean stroke. More than 2, and no amount of trying will ever work. That's all for this video.